Good evening, everyone. Good evening and welcome to live Unacademy's YouTube session. And I'm Rashmi Ahmad. Welcome you to alcohols, phenols, and ethers. We have learned preparations of alcohols and phenols. Today we are going to study physical properties and reactions of alcohols and phenols. To tell you about me in few words, I am working in a reputed college from past 10 years. Okay, I have 10 to 11 years of teaching experience, full-time teaching experience, and plus part-time teaching experience. I have taught in various capacities, prepared students and motivated students to write competitive exams. And I'm working in an academic path from a few months in Karnataka under the capacity of Karnataka CET and Unacademy special classes as well as in YouTube classes. And I welcome you all to this live sessions. Okay, before we go to our subject, let me tell you about Unacademy Plus subscription. Students, if you want to have a comprehensive batch, physics, chemistry, physics, chemistry, mathematics, physics, chemistry, mathematics, physics, chemistry, mathematics, biology, and physics, chemistry, biology, comprehensive batches if you want, live classes where complete syllabus will be, coverage will be there, then you can subscribe to Unacademy Plus. Okay, you can subscribe for 12 months, 6 months, or even for 1 month as a trial period. 12 months you'll be paying this amount, 6 months, okay, this amount, and 1 month this amount. Okay, if you use my referral code Rashmi 2020, in fact you will get 10% discount. You'll be getting 10% discount. Okay, so you can subscribe for 12 months by paying less than 12,375 because you're going to get 10% discount if you use my referral code. Okay, 6 months even less than this because you will be getting 10% discount if you use my referral code, so on and so forth. What are the important details or highlights of this subscription? One is premium content in affordable price, structured live classes, dedicated live doubt clearing sessions. You'll have quizzes, test series, daily practice problems, full length mock test, which will all help you in preparing well for your upcoming exams, and also will help you to understand how much of the concept is really you have taken to yourself. Okay, how much preparation is required. If you understand that some topics or some chapters is not clear to you, what you can do, with a single subscription, you have unlimited access to Unacademy. You can prepare, go back to the library where recorded classes will be there. You can go through that classes, or you can attend any lecture and you can prepare yourself. Now, if you use my code Rashmi 2020, not only you will get discount, other benefits, added benefits you'll be getting. Okay, so wherever referral code is asked, use my referral code to get added benefits. Any doubts, any questions, students, you can put it in the chat session. I hope chat session is available for you all. Okay, is chat session available? Do you get chat session? Do you get students? Let me know. Yes. Okay. Okay then. Okay. As I was telling you, if you use my referral code, you will have all the benefits. Yes. Good evening, Abril, Alok. Good evening, Krishna Kumar, and welcome to Unacademy. Okay, welcome to Unacademy. Let's start our class for today. One more important thing. See, if you take, I just already told you, you can go for 12-month course by paying 12,375 or 6-month course by paying 10,125. And if you use my referral code, you will get 10% discount in this amount. Okay. Now, if you go for this course, within 6 months, the full syllabus will be covered. Okay, remaining you will have test series, complete test series, mock test, everything. So you can prepare yourself well. And no cost EMI also available. Okay, you can also go for EMI on 6 month and above subscriptions. Okay, you can also go for EMI. And every month, okay, multiple batch will be launched, multiple batches. You can search in your app and you can which is the best suited batch for you. You can opt for that. Okay, yes. Let's start today's session. Physical properties of alcohols and phenols. First one is the boiling point. Boiling point of alcohols and phenols increases with increase in number of carbon atoms. If you comparing CH3, CH2, OH with the CH3, CH2, 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 OH. This is ethanol. This will be propanol. Is it not? pentanol, 5 carbon atoms, pentanol. When you compare, as the number of carbon atom increases, okay, as the number of carbon atom increases, surface area increases. Surface area increases. As the surface area increases, van der Waals forces increases. As the van der Waals forces increases, boiling point also increases. Boiling point increases. So these are all directly related. As you surface area increases, van der Waals force of attraction increases, boiling point increases. Okay. So as the number of carbon atom, when we say as the number of carbon atom increases in phenols, we are talking about straight chain. Now, what happens if branching increases? See, so there may be branching, still carbon atom is increasing. But if branching happens, what happens? Surface area decreases. The alcohol molecule becomes globular. They become spherical. Okay, when it becomes spherical or globular shape, round shape, when the increase in branching, they become roundish shape. When the structure becomes round shape or spherical or globular, surface area decreases. When surface area decreases, van der Waals force of attraction decreases, boiling point decreases. Okay, this you should know. Okay, decrease in van der Waals force of attraction because surface area is decreasing, boiling point decreases. So that are the 2 points about boiling point. Third point is, you're comparing between alcohols and phenols and with the hydrocarbons, ethers and haloalkanes and haloarenes. Alcohols, phenols, you're comparing with these class of compounds of comparable molecular mass. Molecular mass should be comparable. If you're comparing alcohols with ethers, molecular mass should be comparable. I hope you get it, because alcohols and ethers are isomers of each other. Is it not? CH3OCH3 is isomer with CH3, CH2OH. When you're comparing, these are comparable molecular mass. When you compare dimethyl ether with ethanol, ethanol has more boiling point. Boiling point of alcohol is more than these compounds. What is the reason? Because alcohols can have intermolecular hydrogen bonding. What do you mean by this? So this is one alcohol molecule. This is another alcohol molecule, ROH, and the alcohol molecule. Oxygen and hydrogen. This is one molecule, this is second molecule. Between the molecule, between oxygen and hydrogen, there is a hydrogen bonding. Okay, because of the intermolecular hydrogen bonding, alcohols have more boiling point, or boiling point increases than hydrocarbons or ethers or haloalkanes or haloarenes. When you have haloarenes means phenols we are comparing. Okay, of comparable molecular mass. I hope you understood this. So when you are comparing compounds of comparable molecular mass, alcohols and phenols have more boiling point because of the formation of intermolecular hydrogen bonding. Whereas in ethers, hydrocarbons, there is no intermolecular hydrogen bonding. There is no hydrogen bonding. They lack hydrogen bonding, so the boiling point is less. That is the same reason why, that is formation of hydrogen bonding is the reason why alcohols and phenols of lower members, okay, are soluble in water. Alcohols and phenols are soluble in water because alcohols and phenols can form hydrogen bond with water. Water also has hydrogen, oxygen. Okay, so there is an alcohol molecule here. Okay, hydrogen bonding, oxygen of water molecule, hydrogen like this, or another water molecule like this, another alcohol molecule like this. Okay, OHR, between hydrogen, oxygen of alcohol and hydrogen of water, hydrogen bonding. So there is also hydrogen bonding possibility is there. That is why alcohols and phenols are soluble in water. But as the alkyl or aryl group increases, alkyl and aryl groups are hydrocarbons, and hydrocarbons are hydrophobic. They repel water. So when alkyl chain length increases, so the aryl group, number of aryl group increases, or what happens? Hydrophobicity is increasing, so the solubility decreases. As that means only lower members of alcohols and phenols, alcohols are soluble in water. As the R group chain length increases, hydrophobic character increases, so they becomes less and less soluble in water, finally insoluble. Okay, so that is about physical properties. I hope you understood. Good evening, Sinan, and welcome to Unacademy YouTube session. Okay, good evening. Any doubt? Any doubt, guys? Did you understand physical property? Any doubt? If you have any doubt, you can ask now. Do you have any doubt? I hope you understood. Clear? Is this clear? Okay, let's continue then. Now, chemical reactions. Now, when I'm talking about chemical reactions, beginning, I'm talking about chemical reactions of alcohols and phenols because I'm talking about esterification. Esterification, both alcohols and phenols undergo esterification, and it's very important. It's very, very important. esterification. Okay. Now, when I'm talking about here and esterification or following reactions, the bond is broken between oxygen and hydrogen. Bond cleavage takes place between oxygen and hydrogen. Oxygen becomes negatively charged, hydrogen becomes a positively charged. Remember alcohols, okay? Alcohols, OH bond breaks. So H comes, you get alkoxide ion and a proton. Okay, OH bond breaks. Remember, OH bond is breaking. Okay, yes. Now let's learn esterification. Alcohols, phenols react with the carboxylic acid or acid chloride. Carboxylic acid, RCOOH, or acid chloride, RCOCl, or acid anhydride, RCO twice O, or can be written as RCOOCOR, like this. Okay, acid anhydride. What does it give? Ester. Ester, general formula RCOOR dash. Ester will be formed. Okay, ester is formed. Ester is formed. Now, let's learn about alcohols. Here in general I have put, okay, let me give you in general now. Alcohols and phenols. Now I will explain first alcohol. You have to write same way in phenol also, because R will be AR, that's all. R is replaced by AR, that is C6H5 group. R is alkyl group. AR means aryl group, that is phenyl group. C6H5 group. Okay. Now between O and H bond is broken. So carboxylic acid, alcohol can react with carboxylic acid, acid anhydride or acid chloride. From carboxylic acid, COOH will come out. So H and OH, water will be formed. So from alcohol H, from carboxylic acid OH, water will be formed. Because water is formed, you are adding acid, okay, as a dehydrating agent, which will remove water molecule. Okay. Now what is remaining? From alcohol, RO is remaining. From carboxylic acid, RCO. You join them. Oxygen is losing bond, no bond is broken. Carbon, RC double bond OOH. Now carbon is losing bond. So carbon of carboxylic acid and oxygen of alcohol will be bonded. So let me show you here. Okay. Next page. It's like this. ROH bond is broken here. Carboxylic acid, OH, C double bond OR. This is carboxylic acid. I have written ulta, that's all. COH. I have written RCOH. Okay. So water molecule is eliminated. Add and write. What is happening here? RO C double bond OR. This is your ester. Ester. And if you want the reaction to carry out in the forward reaction, because this reaction is reversible. If you want reaction to carry out in the right side, water has to be removed. So that is why you add sulfuric acid to the reaction. You add sulfuric acid, so as soon as water is formed, sulfuric acid is a dehydrating agent. Water is formed, water is removed. Okay, I hope you understand. Same reaction can also happen with alcohol. Okay, with the C double bond O R. I have written ulta, RCOCl, that is acid chloride. I have written ulta. So HCl is removed. Okay, in the presence of pyridine, now base you use pyridine. Okay, you get RO from alcohol and COR from acid chloride. You get ester, and byproduct is HCl. So HCl is an acid. Acid formed is neutralized by the addition of base pyridine. Again, reaction will be carried in the forward direction. Le-Chatelier's principle. You remember Le-Chatelier's principle. Okay. So to maintain the equilibrium, okay, when your pyridine removes acid, to re-establish the equilibrium, that is, equilibrium will be re-established by producing more HCl. When HCl is removed, to re-establish HCl, reaction has to be carried out in the forward direction. So we want product ester. So it will be aiding our purpose. Okay. You can also use acid anhydride, that is RCO twice O, that is RC double bond OO, C double bond OR. Okay. This entire molecule will come out as, again, pyridine will be used. RCOOH, carboxylic acid you get. Remaining ROC double bond OR, ester, you will get as a product. Now, so I hope you understood. Same reaction is happening, same way. If you have using carboxylic acid, water is the byproduct, which is eliminated by adding sulfuric acid. If acid chloride or anhydride is pyridine is byproduct, because acid base is added, because acid will be the byproduct, which is eliminated by the base. Okay, so all these reactions were carried out in the forward direction. So you get ester. Now ester has a characteristic smell called as fruity smell. Okay, hence the name esterification, because esters have fruity smell. Fruity smell. Okay, and this test, esterification, is used for test of carboxylic acid. It is a test for the detection of carboxylic acid. Okay, detection test of carboxylic acid. Detection test of carboxylic acid. What I'm talking about? You take carboxylic acid, this acetic acid. If you want to know COH group is present in a given organic compound, okay, if you have a faintest want to check whether COH group is there, to the given organic compound, you add alcohol and add few drops of concentrated sulfuric acid and you heat. If the given compound is carboxylic acid, you will get a fruity smell. If the reaction happens and if you get product, the product, this ester, okay, it's called as ethyl acetate. Ethyl acetate will have fruity smell. Fruity smell. When you get fruity smell, when your nose detects fruity smell, that means the given organic compound is carboxylic acid. Carboxylic acid. Okay, glacial acetic acid means pure. There is no contamination. Okay, pure acetic acid, glacial acetic acid. So it can be used as a detection test for carboxylic acid group, COH group, functional group COH can be detected using esterification test. Okay, now during esterification test, okay, listen carefully. During the esterification test, OH group combines with the H atom of alcohol. OH comes from carboxylic acid, H from alcohol. That is why OH bond is broken to give water. Remember, okay, and you get CH3CO, C2H5. Now, reversible reaction is possible. So, if CH3COO, C2H5 is obtained, this part, okay, this part comes from alcohol. And this is from carboxylic acid. So when it breaks down, you will get CH3COOH plus C2H5OH. This again yesterday I explained. So oxygen hydrogen bond of alcohol is broken. So a proton comes from alcohol. OH minus group comes from carboxylic acid and you get byproduct water. Reaction is reversible also. Therefore, water, as soon as formed, the water has to be removed. Or else reverse reaction takes place, you get back the reactant, that is alcohol and carboxylic acid. You get back the reactant. Now, if acid chloride is used, as I have shown you here, if acid chloride is used, okay, instead of carboxylic acid, acid chloride is used, okay, the byproduct formed has to be removed, no, that is HCl will be acid will be formed. That is why base, a pyridine is a base is used, which to remove HCl during the reaction, so that the equilibrium will shift to the right hand side. You will get more and more ester. Okay. Introduction. Now during whether you are using acid chloride or acid anhydride, you are introducing RCO group, or if R is CH3CO group, this is called as acetyl group, or this is in general acyl group you are using. So this introduction of acyl or acetyl group, also called, if it is acyl in general, you call it as acylation. Or if R is CH3, you call it as acetylation. Okay, so esterification, this can also be called as acylation if you are using R. If you use instead of R CH3, particular acetic acid if you use, okay, then we call it as acetylation. Okay, so esterification can also be called as acetylation if RCO or CH3CO group is introduced. I hope you understood this. Do you have any doubt in an esterification? Esterification is very, very important. Now you have to write same reaction. Instead of R, you write AR. So R will be AR here. That's all. Instead of R, okay, AR. C6H5 group. That's all. Did you understand esterification? Mariam Babu, good evening and welcome. Harshmol, good evening, welcome. Did you understand, guys? Esterification is clear? Is it clear? Okay. Now, important esterification or acylation is preparation of aspirin. Where you are using salicylic acid. What is salicylic acid? Okay, what is salicylic? Priya, good evening, welcome. What is salicylic acid? Benzene ring with the 1-2 position in the first and second position. Okay, COH and OH group is there. COH and OH. When COH and OH group is there, COH is their primary functional group. OH becomes your substituent. OH group becomes your substituent. Okay, so this is benzoic acid, 2-hydroxybenzoic acid, salicylic acid, or called as salicylic acid, 2-hydroxybenzoic acid or salicylic acid. Okay, salicylic acid reacts with acetic anhydride, CH3COO twice. So this is acetic anhydride. When salicylic acid reacts with acetic anhydride in the presence of an acid, okay, in the presence of an acid as a catalyst, in the presence of sulfuric acid, acid is sulfuric acid, you get aspirin. What is happening here? The OH, H will be substituted by acyl group in the place of H of OH. CO, because H, CH3COO, H will come out as CH3COH, acetic acid. So what will be left behind? CH3CO. Group O minus you have, C plus here. So O minus C plus forms bond giving OCO CH3. So acetyl group is introduced. So it is acetyl salicylic acid, aspirin. Acetyl salicylic acid is aspirin. Byproduct is acetic acid. Acetic acid. So esterification you call it as, or acetylation. Acetylation of salicylic acid or esterification. Esterification. I hope you understood. So this reaction is also very, very, very important. This is how aspirin is prepared. Preparation of aspirin. You know what is aspirin, is it not? It's a medicine, is it not? Analgesic, is it not? Antipyretic? Yes. Okay. Next reaction involves the cleavage of CO bond between carbon oxygen, CrOH. Carbon and oxygen bond breaks out like this. So you have OH coming out. So OH will be substituted with some other groups. Now first reaction we are learning where OH is substituted by halogen because hydrogen halide is reacted with alcohol. So OH of alcohol is substituted, see hydrogen halide H plus X minus. So OH minus is substituted by X minus. So this is a substitution reaction. Nucleophilic substitution reaction. OH minus is substituted by X minus. Okay. So you get RX, alkyl halide you get. This is alkyl halide. So when alcohol reacts with hydrogen halide, okay, you get alkyl halide. Now alcohols, there are three classes of alcohols. There are primary, secondary, tertiary. What is the order of reactivity of alcohols? Tertiary is more reactive than secondary. Secondary is more reactive than primary. So this is the order of decreasing order of reactivity of alcohol. Tertiary is more reactive, okay, than secondary. Secondary is more reactive than primary. Now, how do you know this? You can distinguish primary, secondary, tertiary by making alcohol react with hydrogen halide called as HCl, hydrochloric acid you can use, in the presence of a catalyst anhydrous zinc chloride, and the combination of concentrated hydrochloric acid and anhydrous zinc chloride is called as Lucas reagent. Lucas reagent. So this combination, okay, anhydrous zinc chloride in concentrated hydrochloric acid is called as Lucas reagent. So to the Lucas reagent you add alcohol, okay. If it is tertiary alcohol, you get immediate turbidity, because what happens is when alcohol ROH reacts with the concentrated HCl, you get RCl. Now if R group is tertiary, okay, tertiary alkyl halide is not soluble in HCl. You have HCl, alcohol is converted into alkyl halide. HCl will be there in excess here. This tertiary alkyl halide is formed not soluble in HCl, so you get turbidity. The turbidity means insolubility. So insolubility, precipitate, it looks like kind of solution becomes turbid. You get immediate turbidity. If you get immediate turbidity, that means immediate product is formed, that because it is tertiary alcohol. Now turbidity is formed after 5 minutes. Again, secondary alkyl halide is formed, but it takes time. That means it is secondary alcohol. After 5 minutes, after 10 minutes, you are not no reaction, but turbidity appears after heating. Only after heating. Only after heating if you see turbidity, that means it is primary alcohol. So among tertiary, secondary, primary is least reactive because it reacts only after heating with the Lucas reagent. So if alcohol reacts immediately with Lucas reagent, that is tertiary alcohol, because tertiary is more reactive. Then after 5 minutes if you see reaction, secondary alcohol reaction if you see only after heating, that means it is primary alcohol. And this test distinguishes primary, secondary and tertiary, and this test is called as Lucas test because you are using Lucas reagent, so it's called as Lucas test. And Lucas reagent is mixture of concentrated HCl with anhydrous zinc chloride, and this test distinguishes between primary, secondary and tertiary alcohol. Lucas test. And this is the reaction. Alcohol react with HX or HCl, in this case HCl, giving RCl. I hope you understood. If you want to understand it better, this is like this. Tertiary alcohol will have like this, is it not? 3 carbon attached to it along with OH. Along with HCl, you get are 3 times CCl. This is tertiary alkyl halide. So tertiary alcohol will give you tertiary alkyl halide. Tertiary alkyl halide. Okay, immediately. So you get turbidity, clean test tube. Otherwise, this will be clean. Alcohol dissolves in HCl. Alcohol dissolves in HCl, but the product formed is not soluble. So it will appear as turbidity. Okay, the clean solution becomes opaque. Turbidity. That is called as turbidity. Did you understand Lucas test? This is important. This is important. Did you understand Lucas test? Guys, did you understand Lucas test? Yes? Where OH bond R and OH is coming out. So CO bond breaks. CO bond breaks. Okay? Yes. Let's go to the next reaction. Reaction with phosphorus trihalide. Okay? When I say trihalide, your X is usually Cl. Or it can also be Br. Okay? PCl3 usually. It is PCl3. So alcohol reacts with phosphorus trihalide. Okay? Same thing. Carbon-oxygen bond is broken. Okay? OH is replaced by X. So you get alkyl halide. Alcohol, when reacts with PCl3, you get alkyl halide. Alkyl halide. Alkyl chloride or alkyl bromide. What is the byproduct? What is the byproduct? What is remaining? Since 3 molecules of alcohol, one with the 1 molecule of PX3, 3 molecules of, okay, because 3 halogens are there. 3 molecules of alcohol react. Because 3 halogen atoms are there, 3 OH can be replaced by halogen. So you have 3 R group and you have 1 P. Okay, 3 hydrogen, 3 oxygen which is coming out. Okay, so R with the X, 3 RX you get. Now what is remaining? 3 oxygen and hydrogen and 1 phosphorus. Phosphorus and 3 oxygen hydrogen will combine to give you H3PO3, phosphorus acid. H3PO3 is the byproduct. I hope you understood this. Okay, since there are 3 halogen atoms, 3 alcohol groups can react. So byproduct will be H3PO3 because 3 hydrogen, 3 oxygen is remaining and phosphorus from PX3. So you get H3PO3 is the byproduct. Phosphorus acid is the byproduct. Okay, alkyl halide and phosphorus acid. Okay, example you see, ethyl alcohol or ethanol react with the phosphorus tribromide. Okay, you get OH is replaced by Br. Since there are 3 Br, 3 molecules of ethyl bromide you get. So what is remaining now here? 3 alkyl group is used. So 3 OH groups are there. 3 oxygen, 3 hydrogen with the 1 phosphorus will give you H3PO3. See, H3PO3 byproduct. That is another reaction. Again, alkyl halide. Alcohol is converted into alkyl halide. So these reactions, same way you learn, this can also be learned under the preparation of alkyl halides. Okay, because alkyl halide is the product, no? So in haloalkanes chapter, you'll be learning the same reaction under the preparation of haloalkanes. Same reactions under the preparation of haloalkanes. Is it not? Okay. Third reaction is dehydration. Dehydration. What is by dehydration? Hydration is addition of water molecule. What is dehydration? You are removing water molecule. So what is the dehydrating agent? Dehydrating agents are usually protic acid like concentrated sulfuric acid, phosphoric acid, H3PO4. This is phosphoric acid. Phosphoric acid. Okay, H3PO3 is phosphorus acid. H3PO4 is phosphoric acid. Also, dehydrating agent can be used as a catalyst such as anhydrous zinc chloride and alumina, Al2O3. Al2O3 alumina. You can also use catalysts like zinc chloride and alumina as can also used for dehydration, for removal, water molecule. Okay, so what are you carrying out dehydration? Alcohols are dehydrated. From alcohols, when you remove water molecule, how do you remove water molecule? The carbon, this is called as alpha carbon to which OH is attached. From the alpha carbon OH comes, the next carbon, beta carbon H comes. So water molecules are eliminated. Between alpha and beta, you get double bond. So you get alkene. Alkene is the product. Alkene is the product. I hope you understood this. So OH comes from, so what I am trying to tell you is, from the same carbon, water molecule is not removed. Okay, so OH comes from one carbon, from the other carbon, next carbon, beta carbon. Okay, from beta carbon, H comes out. This carbon also has H here. There are 2 hydrogen atoms, but that from the same carbon, H and OH is not removed. H comes from the next carbon, beta carbon. Water molecules are removed. See, for example, CH3, CH2, OH. So this is the alpha carbon because OH is attached to this carbon. Okay, or the first carbon. You can call it the first carbon, second carbon. So from the first carbon, OH comes out. From the second carbon, H comes out. So between first and second, so you get double bond. You get alkene. And since you have taken ethyl alcohol, you get ethene. This is ethyl alcohol. So you get ethene. Ethene molecule is the product. Okay, and what is the temperature maintained? Temperature is 443 Kelvin. You have to maintain this temperature. At 443 Kelvin, ethyl alcohol will give you ethane if you use sulfuric acid as a dehydrating agent. Temperature is very, very, very important. At this temperature, using sulfuric acid, you can dehydrate ethyl alcohol to ethene. I hope you understood it. With that, I will wind up today's class. Mechanism of dehydration we will learn in the next class. Okay, mechanism. Again, mechanism is very, very, very important. We will learn the mechanism in the next class. Do you have any doubt? Any question? Any doubt? Do you guys understand? You have any doubt? Any question? Any doubt, guys? Okay, no doubt. Then we will see you. I'll see you in the next class.